Let's now look at this confidence interval problem involving a small sample, 16, and an upper bound, one-sided confidence interval. We have a mean pH of 6.68 and a standard deviation of 0.2. We have approximately normal behavior from the probability plot, so that means that the t-distribution applies. Find the 95% confidence interval that gives an upper bound. Okay, so the form of the answer is going to be mu is less than, well, the average is 6.68, and I'm going to modify that average, 6.68, by a certain amount. So plus, well, the standard error is going to be equal to 0.2 times the square root of 16, or excuse me, divided by the square root of 16 because it's an average problem. And then the thing that's going to be left is going to be a certain value off the t-distribution. Now, what number is it? For that, let's just draw a quick little picture over here to the right. So I need the number. So I have a t-distribution. In this case, I have 15 degrees of freedom, n minus 1, because n is 16, so I have a t-distribution with 15 degrees of freedom. And in my case, I want the area to the left to be equal to 0.95, because it is a one-sided confidence interval. So the area to the left has to be equal to 0.95, and so the area under here has to be equal to 0.05. And so our symbol is that this number is going to be t sub 0.05, corresponding to 15 degrees of freedom. Okay, so that's the number that's going to appear here, 0.05, comma 15. Now, how do we get that number? Now, the way that we get that number depends basically on which calculator you're using. If you're using Microsoft Excel, we've seen that the command tinv will return percentiles off the t-distribution, and that also has a similar command on the TI-84. So let me show you that to you here. So the way that I'm going to get this command is going to be second distribution, and there on the TI-84 plus there is a command invt. And some of you have said to me in the past that you don't have this kind of screen when doing it, but we have an area of 0.95, that's the area to the left. So notice that I'm putting the area to the left here, not the area to the right, and also 15 degrees of freedom. And this will return the 95th percentile of the t-distribution with 15 degrees of freedom. In other words, 5% of the area lies to the right. Okay, so I hit enter. So that's the command that I have. Now, if you did not have the screen that you had before, just know that invt takes two arguments, 0.95, comma 15, and this is approximately the same input that you would use on a TI calculator, on a Microsoft Excel, using the command using the invt command, or the tinv command in Microsoft Excel. Okay, so I hit enter, and this is actually being computed, and then we get the answer of 1.753. So that is the answer using a TI-84 calculator. Now I emphasize on TI-84. Here we have the TI-83 calculator, and when I turn this on, notice that there's no invt option here. It has an invnorm function, but it does not have an invt function. So this command is only for the 84 plus, and presumably the more advanced TI calculators also have a function like this someplace built in. Now, if you don't have a calculator that does this, and you don't have Excel, then you have to settle for the tables. And we've discussed how to use the tables in class, and there are other videos on the website that discuss how to look up the appropriate T number on the tables. So anyway, 1.753 is the number. So over here we have 6.68 plus our number, which was 1.753, times 0.2 divided by the square root of 16. And so that leaves us to the upper bound of 6.68. Well, let's go ahead and just do the calculation on the calculator. So 6.68 plus the answer, times 0.2 divided by the square root of 16. And so I hit enter, and I get my answer of 6.768. And because I only have two decimal places, I'll just stick with the two decimal places here, so 6.77. So there's my upper bound. The biggest that mu can be is 6.77 with 95% confidence. So the thing to remember on a problem like this is that we need 15 degrees of freedom, and then we also need to correctly get the number of the t-distribution, the critical value of the t-distribution, whether it's using a TI calculator or using Excel, or else using the tables that'll be provided on the exam.